This video is on the objective understand all forms of the Pythagorean identity, and this is number 2, so the second video on this particular objective on a question related to this objective from your Newton-Alta homework. So probably going to be a little shorter than the first one. Not going to go into as many explanations. It'll be pretty similar to how the first one went. So let's take a look. So again, if you're unfamiliar with the topic, please click on more instruction, look at their videos, their examples, their notes, and hopefully those help. All right, so we're given that the tangent of some angle theta is 5/12, positive 5/12. And theta is in quadrant 3, right? So when I draw theta in standard position, it'll be ending in quadrant 3. What is the cosine of this angle? And they want us to write the answer in exact form. Don't round that. That just means don't put in your calculator. All right, leave it the way it is when you do it by hand. All right. So like I did in the first video, I'm going to show you 2 different ways to do this. All right. One is with we've seen something like this in a previous chapter. I'm just going to draw a picture. All right. So I'm going to go to paper here, and so one way is without the identities. Get rid of the calculator. One way is without the identities. And I personally like this way. Now I would still recommend that you try it with the identities, because you do have to learn those, and the more you write them out, the better you'll probably remember them. So we're given the fact that the tangent of this angle theta is equal to positive 5/12. Right. And we're also given that theta ends in quadrant 3. And we are asked to now find the cosine of this angle. Now, if the angle is in quadrant 3, the cosine should end up being a negative number, correct? Right. Remember, cosines are related to x-coordinates. And when you're talking quadrant 3, right, which is down here, the lower left quadrant, x-coordinates are negative. So when I'm done finding the cosine of theta, it should be a negative number. All right, so I'm going to draw an angle in standard position. Right, so it's starting from the positive x-axis. And I just want to draw it so that it ends in quadrant 3. So you can go counterclockwise, clockwise, doesn't matter, I'll go clockwise. Draw a negative angle. Doesn't matter, as long as there's theta, as long as it ends in quadrant 3. Now, as we typically do, I pick a point on the terminal side. This point has an x-coordinate and a y-coordinate. I do not know what they are. I'm going to try to find what they are. Right? So what is the x-coordinate? What is the y-coordinate? And then I also want, what is r? The length of the you're going to see a right triangle in a second. That's just the distance to the origin, this r. Remember, r has to be a positive number. X and y will both be negative because I'm left and down here. But all right, so then I pick this point on the terminal side. I draw a perpendicular segment to the horizontal axis, to the x-axis, and that creates this little right triangle here. Hopefully you can see a right triangle. And in this right triangle, I have, the reference angle. I'll call it capital R for reference angle. Right, that's the angle formed by the terminal side and the horizontal axis. And, if the tangent of theta is 5/12, the tangent of this reference angle also needs to be 5/12. All right, so I'm going to set up this triangle here so that the tangent of my reference angle is also 5/12. All right, so that means, remember, tangent is opposite over adjacent. So the side opposite the reference angle has to have a length of 5, and the side adjacent to the reference angle has to have a length of 12. Now, because this is left and down of center, I'm going to call these negative, right? We're negative 12, negative 5. So those are the x and y coordinates of my point here. negative 12 for the x-coordinate, right, the left-right, and then negative 5 for the y-coordinate. Now all I need to find is the hypotenuse, this distance from the point negative 12, negative 5 to the origin. And that's using the Pythagorean theorem, right? Negative 12 squared plus negative 5 squared must be equal to this r squared. This is 144 plus 29, that's 169. 144 plus 25 is 169. So r is equal to, again, plus or minus 13, but use the plus, right? Use the plus, because this r is always a positive quantity here, right? R is the distance to the origin. And then I can now easily, now that I have all the sides of the right triangle filled in, now I can easily find what they want, right? They want the cosine of theta. And hopefully you remember the relationship between x and y and r to find all the different trig functions. You know, cosine, remember, was the x-coordinate of my point on the terminal side divided by the r, divided by the radius. Or just look at my right triangle here and use the reference angle, do adjacent over hypotenuse. That was also cosine. So that'd be what? Negative 12/13. And that's what they want. The cosine of, if they gave me this information right here, that's all the information they gave me. What was the cosine of this angle? It's negative 12/13. Alright, so that was without the identities. Now, hopefully you remember the Pythagorean identities, right? The title of this objective is Understand the Forms, pardon me. And so hopefully it's called Understand All Forms of the Pythagorean Identity. And this was in the first video also on this objective. I put up, that refreshed your memory, hopefully, as to what the Pythagorean identities were. They were all these ones that involved, two trig functions, squares, and the number 1. We had the sine of theta squared, the sine of an angle squared, plus the cosine of that same angle squared would always be equal to 1. And then dividing through by sine squared, we'd get 1 plus cotangent squared equals cosecant squared. And then taking that same first one here and dividing through by cosine squared, we'd have tangent squared plus 1 equals secant squared. Well, look at what we're given. Right? We were given the tangent. So in order to find another trig function, I need to use this identity here with the tangent, right? And if I know the tangent, I can then solve for the secant. So I'm going to go through that same problem, and we're going to end up with, negative 12/13 again, but this time with an identity, with those Pythagorean identities. So this is with an identity. So I'll write out what I was given again. The tangent of theta was 5/12, and theta ends in quadrant 3 when you draw it in standard position. So I'm going to use that Pythagorean identity involving tangent. Right, the tangent of an angle squared plus 1 will be equal to the secant of that same angle squared. And I know the tangent, then I can find the secant. So I plug in the value of tangent, right? The tangent of theta is 5/12. So 5/12 squared plus 1 will be equal to the secant of theta squared. 5/12 is 25 144ths plus 1 equals secant theta squared. Get a common denominator here. This would be 144 over 144. Put them together, you get 169 144ths equals the secant of theta squared. Now this is what the secant of theta squared is. So the secant of theta will be now plus or minus. Plus or minus. Now theta is in quadrant 3. Because theta is in quadrant 3, the secant of theta will be negative. So that's why I'm going to use the negative square root of 169 over 144. If this was a different quadrant, right, if theta was in quadrant 1, then I'd use the positive square root. But we're in a quadrant where, the secant of this angle theta will be a negative number, so that's why I'm using the minus square root. And so we have negative, 13 twelfths, right? The square root of 169 is 13, square root of 144 is 12. So I know now, using this Pythagorean identity, that the secant of theta is negative 13 twelfths. And then we just use our reciprocal identity, right? We have to find the cosine, right? So that means the cosine of theta is negative 12 thirteenths, right? Is this the reciprocal of that? And that's exactly what I got on the previous page. Right. So either way is fine, but I suggest to you to practice using these identities, these Pythagorean identities, and because you're going to have to know them eventually, right? If you don't know them already. You should memorize these, all the Pythagorean identities, the even-odd identities, the reciprocal identities, the quotient identities, the co-function identities. Lots of basic identities for you to memorize. So practice doing it this way too, and get on that. Get on learning those identities a little better. All right, so let's go back and enter this value and see if I'm right. So negative 12 thirteenths was the cosine of this angle. Fantastic. And of course, read through their answer explanations, see they're using that same identity and all the same stuff. Okay. So hopefully this video helps you. It gives you a little idea as to what you're going to be doing with problems like this, and for this particular objective. And thank you very much for watching.